Hello, my name is Olga Klinsevich, and today we will discover a very interesting subject, designing installations with flat stations. But at first I would like to say some words about us, about our company, about InstalSoft, about our products, about InstalSystem 5. So here is our website, instalsoft.com, and all necessary information about our products is presented here. You can find the description of InstalSystem 5, available models, and among them the model which is related to our today's topic, flat stations. You can read the information about this model here. Available market versions, you can download demo version, you can buy full version, or you can check the available customized software versions and also discover the advantages of our software and find all the information about InstalSystem 5. Here is our support. First of all, help system. A lot of educational articles on different languages are presented here. And also we provide you introductional videos and trainings and advices. Here you can find the info about available trainings that we provide to you and also order training on the necessary subject. And of course, information about our company is presented on our website and our contact list. And also from our website, you can move to our social networks and to our YouTube channel. It is also one of the kinds of technical support that we provide to our users. Please pay attention that we have InstalSoft Global channel and InstalSoft Polska channel. The information in Polish language is presented here. So here on InstalSoft Global channel you can find video tutorials and video materials on different topics in several languages also. I would like to encourage you to subscribe to our YouTube channel and to our social networks so that we can timely inform you about our news and important and interesting events. This is very briefly about us, and now let's move to our main subject. We start from the InstalSystem 5 Manager. Here you can find several buttons with different functions. Here project management, activation or deactivation the program, update the program, our help. Pay attention, here you can send a report with problem with license or activation, ask a question or report a problem with project. Here you can find license agreement text. Please pay attention on this side. Here you can find the information about models available in the current license configuration. And to have the ability to design installations with flat stations, you need to have following models available in your current license configuration: flat stations, heating systems, radiant systems as an option if the station is supposed to supply an apartment radiant system with heating medium, and tap water systems if calculations for the flat station and the supply system should include flow rate of a sanitary system designed with InstalSystem 5. And here is our online help system. And here we can find several articles related to the installations with flat stations. First of all, this is designing lesson, which shows how to use flat stations in the project with water supply and radiant heating installations. Here you can find and download the file with the example of the project with such installations and study it. Another article that can be helpful in studying our topic is this sample project of convective installation and water supply system with flat station. Here is the article and here is the file that you can download and study. And one more article which can be very useful, is this one, heat source dimensioning for installations with flat stations. And here are video tutorials. This is our YouTube channels. This is the button to our website. It's very easy to subscribe to our channel, and also changes in the license. So, project management. Here you can find the information about recently edited projects, and from this project management you can create new project or open the existing one. What is important to know when creating new project? You can choose the template from the list of templates. And where does this list come from? You should know that in our program you can save the data for different types of projects and then use it as a template when creating the new one. This is very convenient and speeds up the design process. Here is the same sample building, which is used in the examples presented in our help system. But here we have a combination of radiant heating system and convectional heating system with radiators in order to explore the use of the flat station in both variants. And here we have also water supply installation, and this is the first floor of the building. How to create heating and water supply installations we will not explore today. You can find all necessary information on our YouTube channel. Video tutorials and webinars on these topics are presented here, and also you can find articles related to these subjects on our help system. And traditionally, like any new project, we will start by filling out general data. And the first point here to pay attention to is project scope. Here you can choose necessary project scopes. What is important to know? For example, if you design only water supply systems, and you know that heating systems have already been designed also in InstalSystem 5, you can turn this project scope on, and in this case you will have the ability to observe this installation also to avoid collisions. This is really a very useful option. Next point is catalogs. Here we can find products and producers available in the English version of our program. For convenience we can use these filters. Here is flat stations. As you can see, we have one producer here. And also you need to know that we have neutral catalogs developed by our specialist. Here is flat stations, sample solutions. Here is the icon of flat station. These catalogs can also be used in the product. If we want to use catalog, we need to direct it to this zone, catalogs in the product. Like this. And the next point we are interested in is thermal systems, sources. Here we need to pay attention to this value, the value of default supply temperature of medium in heating systems. It is 70 degrees now. And the next is flat stations. Here we can put the data that will be used by the program by default. This data we can also change during the design process. So let's start from the type of flat station. Here we can see neutral catalogs, sample solutions, and also the catalog of the producer that we selected before. Here we can find how the station looks like. What you should pay attention to is the selection of subtypes of flat station variants determined by the size of the heat exchanger. The program itself doesn't offer automatic selection of the heat exchanger. We need to select it manually to have the possibility to influence the technical parameters that are of key importance. Of course, in the process of designing, these parameters can be changed. And in our project, we will use two types of flat stations for underfloor heating and radiator system and for radiator system. The next is cabinet type. We can choose from two types. Let's choose this one on wall, manifold cabinet. Next field is key to the operation parameters of the installation, hot water heating degree. We can choose between two variants for neutral catalogs, 35 or 40 kelvins. This option depends on what characteristic the producer represents. Most often we have 35 or 40 kelvins. Next field is manner of defining hot water outflow. It can be user specified. In this case, we need to put this value manually, or it can be taken from the model water supply systems, if this model is turned on in our product. And today, during calculations, we will look at both variants. The next one is flat station installation height. The next is the coefficient of flow reduction in primary circuit. Enables correction of the flow determined by the program according to selected calculation method. As we have water supply model turned on, we will also check it. We have here flat station, and it's just the same type and cabinet type and other parameters as we enter for thermal systems. And as I have already said, as we have the water supply model turned on, we have two variants to define this field. And if we will turn it off, we will have only one variant. It will be user specified. So that's all about general data, and we are moving to the 2D editor. So, we have prepared plans with partly completed systems. As you remember, here are risers for heating system and for water supply system. Here are radiators and sanitary appliances installed and connected by pipelines. And also we have underfloor heating zones, which are also connected by pipe feed route. As I have already mentioned how to create such systems, you can learn from our help system articles and on our YouTube channel from the appropriate tutorials. And let's start from this part with underfloor heating zones. To make the design process more convenient and clear, I will turn off the visibility of this step of water supply systems. I will choose invisible when inactive and return to the convectional tab. And here in the main tools bar, I will choose this option, flat station, and we'll put flat station somewhere near the riser. Let's turn it. And now please pay attention to these symbols. These two show the place of connecting with heating riser. This is the place of connecting water supply system. And this is the place of connecting underfloor heating zones. And here in the data table, now we can observe and change, if necessary, the parameters of selected flat station. So, the type of flat station is taken by default from general data. You can see that we can change it here. Cabinet type is also taken by default by the program from general data. And here the position of optional set. We can add necessary sets. For example, we can add heating secret connection, and please pay attention how our flat station will change. 2 icons added. This is a connection from radiators. But we don't need it here in this place, and we just turn off this option. The list of additional elements will depend on what a particular producer offers. If we place these elements, they will appear in the bill of materials, and also these elements in the system will create additional resistance. This resistance should be and will be included in calculations made by the program. Here we have hot water preparation parameters. It is also taken by default from general data. And below there are characteristics related to the equipment located in the flat station. This is manifold, mixer, balancing valves, pump, and differential pressure controller, the aim of which is to stabilize the flow on the heat exchanger. So we are ready to make connections. We choose supply and return pipe runs and just make the connection with the riser. And the next step we will make in this step, and we will choose pipe fits route to connect the manifold located in the flat station with the underfloor heating zone. Let's move a bit, choose this function and make such connection. And now let's move to the next flat station. Here is our riser. And you remember that here we have only convectional heating system. So we go to the convectional tab, and here we choose flat station, and again put it somewhere near the riser. And now in the data table we will change the type of this flat station, which was taken from the general data by the program by default. We will change it on this one. And now you see that we have the opportunity to connect with radiators, with riser, and also with water supply system. And let's turn it also and make necessary connections. We choose supply return pipe runs, make connections with the riser and with heating system. And by this way we make connections with the rest part of our heating system. All necessary connections are made, and now we are ready to run calculations. So it's finished, and you can pay attention to the color of this icon. It is yellow. That means that we have only warnings after our calculations and we can continue our design process. And now let's pay attention to this hint. This is a table with technical characteristics of the flat station. Here we can find the type of flat station, supply temperature that we put in general data, and total pressure loss. The value of supply temperature here is slightly different from the value we put in general data, 70 degrees, because the program takes into account the minimum temperature drop in the risers. The following area relates to the station operation in the hot water preparation mode. Here we can find hot water outflow, hot water heating degree, mass flow rate, tap water heat exchanger output, pressure drop, and return temperature. And you remember that we enter the value of hot water outflow in the general data window as user specified. The next field relates to the heating mode, heating output of heating side, and return temperature. The next field is valve characteristics, its type, pressure drop, minimum pressure drop, and flow coefficient. And the last one field for this flat station is differential pressure controller characteristics. And please pay attention here for this flat station. For the flat station which is used for underfloor heating system, for radiant system, we have additional field with the characteristics of the mixer. So this was the first scenario when we declared manually the value of the hot water outflow. Now we will look at the second scenario, the second variant, when it will be taken from the water supply system model. In the general data window, here in the tab of flat stations, we will change this option according to the calculations of the model water supply systems. And let's look here to this tab in the water supply systems model. We have the same value. And one more important point to know, the new release of the InstalSystem 5 is coming, release 24. And there will be one more novelty in this model, in the model of flat stations. Now primary network can be sized according to TU Dresden method or DIN 1988-300. Starting from release 24, there will be two additional methods, DIN 4708 and VDI 2072. So we return to the 2D editor. I will turn off, will make invisible when inactive, the scope of convectional and radiant heating, and I will leave only water supply, also this. And now we will make connections with water supply system. So we choose this pipe run and make connection with the riser. And now we will make connection with the water supply installation. By this way we connect all flat stations and all necessary connections are made, and we are ready to run calculations again. We can do this by using these icons to make separate calculations of heating model and of water supply model. And we can use this big button with calculator. Just we need to check off unnecessary project scopes. For example, we don't need to make calculations of building structure now, and our calculations of heating systems and water supply systems will be completed faster. So we run calculations. Let's turn on these project scopes. And this is how our installations look on 3D. To observe each, we can again change the visibility of project scopes. I will choose this, the only one visible when active. And now we can see convectional system with radiators. Here flat stations, you can see pipelines, connections to radiators and connection with the riser. We do the same with our radiant system. You can see connections. And also water supply system. Here we can also observe flat stations and connections with sanitary appliances. And we return to the 2D editor, and here again we are interested in this table with technical characteristics of flat station. And the position we will pay attention to is hot water outflow. This value differs from the value that was here after previous calculations, because now it is calculated based on the flow balance of the water supply system connected to the station, according to the tap water system's calculation standard selected in this model. Since we have a repetitive layout on the first, second and on the third floor, we can copy the part of the system we created to the floors above. To do this, we hold the Ctrl key and select necessary product scopes, its convectional heating system, radiant and water supply system. And then here we will choose this function, select all or select components in rectangle. We will select all and then we will choose this function, copy selected elements to multiply stories above. In the case when we would like to make copy to one story above, we can choose this function. If we would like to copy selected elements to several stories above, we will choose this function. And here we will specify the desired range to the set story. OK. So here is the third floor, here is the second floor, and let's see how it looks on 3D. Here are the systems, and here we can see our flat stations on each floor, risers, all necessary connections. So, as you can see, it took us a few seconds to create such systems. It's of course very convenient, and I would like you to know that every day we work to make the design process in our program as convenient and easy for you as possible. And we can run calculations. So here are our installations, and we can change the visibility, gradient and loops drawing with Ctrl key, and we can see loops drawing, we can see all connections. Once again, here is convectional installation with radiators, flat stations, risers, and let's observe water supply installation. We'll make it the only visible when active. That's how it looks. Here is also risers and flat stations and sanitary appliances. And as you can see, icons of calculation models of heating installations and water supply installation are yellow. That means that we don't have any errors that will prevent us from continuing our calculations. And let's return to the 2D editor, and here I will show how to copy separate parts or separate elements of the systems. So to copy separate part, you can choose this function, select components in rectangle, and just select necessary components and make a copy using these icons. To copy separate elements, please pay attention, we have project browser. Here we can choose, for example, this scope water supply systems, and if you would like to copy, for example, flat stations, we can choose this position and we can select in rectangle components of defined type. And as you can see, only flat stations are selected. Or we can use this function select all. In this case, all flat stations on each floor will be selected. So that's how we can find and choose elements with the project browser. And now we can turn our attention to the diagnostics window. Here we have only one warning related to the flat stations. Flat station has been detected in installation. Verify the need of a heat buffer of the required capacity. So, this warning appeared because we don't choose any particular producer of the flat stations in our project, and in general we have only one producer of flat stations in our program, and it's Gamma company. We have only one rule provided by this company related to the applying of the buffer tanks in the installations with flat stations. And as there is no common rule related to such cases, we display this warning so that designer can decide by himself how to act in these cases. And now I would like to present you a situation with the most common error, which prevents further calculations and further designing of the systems with flat stations. So let's change our general data. I will change default supply temperature, for example, for this value. And let's run calculations. Please note that now we have an icon of heating systems calculation mode red. That means that we have error which not allows us to continue our designing. So let's open diagnostic window, and here is it. Heat exchanger in flat station out of range of permissible working parameters. So that means that our flat stations can't be used in the system with such parameters. What we can do in such situations? We can change, of course, this value. We can change this value. Also, we can change this value if here we have user specified method, of course, and we can choose manually other size of heat exchanger in flat stations. Let's run calculations once again. By the way, we can turn on this scope. In this case, we will see the result table after calculations. Here it is. Let's analyze it. So first of all, it's general results. Here we can find supply and return temperature, summary total output, and please note that in systems with flat stations, you can find separately the value of total output in heating season and the value of total output in summer. Because in summer there is no need to heat buildings and rooms, and we can reduce this value. So here is the value of total output of heat exchangers in summer, total output of convectors, total output of radiant heaters, and not utilized heat loss of pipe runs and losses of radiant systems within source feed area. Available pressure and capacity of system, including terminal units. Another important field is this one, elements in flat station. Here we can find the table and analyze in details the components and their parameters inside the flat station. This makes it easier to check the correct selection and definition of the station components and the hydraulic resistance created by them. And also, additionally, for such components as balancing valve and differential pressure controller, we can see the presets. And also we can find the information related to the flat stations here in heating cooling secrets. Here we can find each secret from source to receiver. Here is the element of flat station. Using this icon, we can find this element in all active windows. And by this way, to analyze the system and its elements. And for the convenience, we can place necessary windows together to have the opportunity to observe necessary element and to analyze it on one screen. Let's close them. And of course, list of flat stations. Here we can see the list of flat stations which is used in our product, its quantity, the list of cabinets, their sizes, and the list of valves that is used in the product. And we can print the results tables, send it to PDF or save in any appropriate format. Another important aspect related to the calculation results is heat source dimensioning. In case of designing installations with flat stations, we recommend that you always consult the producer of flat stations with regard to the dimensioning of the heat source. In the case of particular data, one of the following decisions should be made. If the heat source doesn't have a buffer tank, in this case, dimension of the heat source, the total output value should be assumed. If the heat source includes a buffer tank, the specified total output value is the peak output that the buffer tank must supply to the installation. We suggest that the heat source should be sized for the standard heat load of the building, or, in the absence of standard calculations, for the total heat load of the rooms, including not utilized heat loss of pipe runs and losses of radiant systems to outside of source feed area. And now we can generate schematic view. Here is a working menu for this purpose. We will move to the basement and we will put starting point here on the source and we'll generate schematic view. So it took a few seconds and let's look here. One more field appeared. It's our schematic view and we can observe it. So here is our source, rises, flat stations, radiators, and also radiant heating zones. And let's pay attention to the data table. Here we can change the symbol of schematic view, and also we can change the parameters of schematic view. We can change the positions that are presented. So if we will uncheck these two and make generation again, we will have only source, pipelines and rises, and flat station, of course. Also in the data table we can change automatic labels. We can choose the positions to which these automatic labels will belong. And remember please that in the general data window we can change the configuration of the labels. For example, we can change labels for flat stations. Here, pressing on this button, we will see edit and menu for this label, and we can change these options and also font color and height and its style and fields which will be shown on this label. We can turn off or on necessary fields. So as our plans are ready and we generated schematic view, we can prepare our drawings for the print out and export. To do this, we go to the print out tab, and here in the working menu we will choose page layout and put it on the drawing. Here in the data table we can change its format, orientation, scale and other parameters. Also here we can enter drawing chart, and in data table we can choose its type and change its sizes and enter necessary data. So from here we can print our drawings, we can export it to DXF or DWG file. Here we can choose the file format, the version of AutoCAD, and change the configuration of worksheets, and also here we can choose the elements which will be exported. And the important feature of InstalSystem 5, the opportunity to export to IFC format. Here we can also choose the elements which will be exported, change the configuration of worksheets, and make the export. So I think this is all about designing installations with flat stations. I hope that this information will be useful for you. Thank you for your attention and goodbye.